In this video, we will look at Ohm's Law and Watt's Law. We will start off first, though, with a review of electrical terms, and then we'll learn the basics of the laws, and then we'll eventually look at equations and solve for missing terms in the circuit. So if you don't already have a copy of the chart that looks like this, you need to either print it offline or get a copy from your teacher. And then you're going to fill it in as we go along in the video. Remember that you can pause the video and write stuff down or pause at the end. So we're going to be going through and defining what is a current. So the symbol for current is I. And if you wonder why it's I stands for intensity of electron flow. And so current is how the electrons flow through a conductor. And the unit is amps or ampere. We'll say amps, AMP. Well, that's what everybody says. Voltage is electromotive force. And so again, you wonder why we don't put V, and some people do put volts. So you could be doing volts or E, though, is a symbol because electromotive force. And basically it's a measure of this force, and sometimes it's described as electrical pressure, so pressure or force. And you will see it listed as volts. Don't use V, just straight V, because that's a volume. So think of VOLT, write it all out. Resistance is R for resistance, and it's the opposition to current flow, the resisting flow. And you can either write ohms out or this is the Greek symbol for ohms. For power, it's going to be P. That one's pretty straightforward. And power is the rate at which work gets done. So the rate at which that work is getting done in the circuit. And then that symbol is P, but the units are watts, W-A-T-T. So we're going to be looking at two types of circuits as we do this entire unit. The first type of circuit is series. And a series circuit will look like this, where it's a closed circuit and the current flows in one path and then comes back. So they're all in one line. For a parallel circuit, it's closed, but the current is divided into paths and with equal current through their resistance, and then it comes back at the end. So we'll be looking at series and parallel later on. Let's go through Ohm's Law now. Okay, so for Ohm's Law describes the relationship between voltage, current, and resistance. And it states that the voltage equals current times resistance. It looks like this: voltage, which is E, equals current, I, times resistance. When two letters are side by side, you don't have to put a operation symbol in between them, but you might find that putting the multiplication symbol or a dot will help you when you go along towards doing the actual operations. Watt's law is describing the relationship between power, current, and voltage. And it states that power is equal to current times voltage. And so for Watt's law, you've got power, P. I was thinking of this as pi. Power equals current, I, times voltage. So it's pi. Now this sounds like a whole lot of stuff to remember. And of course, you don't have to remember this, all these different relationships. You're going to get a chart that looks like this. And I've written down these words here. So power is green, the P you'll see in the center, the watts, current, resistance, and voltage. And so if you know two things, so like for example, if you know the current and the resistance, you can find the power, or if you know the voltage and the current, you could find the amps. So, sorry, not the amps. If you know if you have the current, you already know the amps. If you find the voltage and the current, you could find the resistance. So we're going to use this chart, and I will show you how to use it. If you don't have a copy of this chart already, you should find it on your formula sheet. You can also print it offline and ask me for a copy. So here's how we use it. Here's a question. It says find the voltage in a circuit with a 3 ohm resistor and 4 amps of current. So I want you to start off and think, what do you know? What are the pieces that you know? Okay, and we're going to label them. So in this case, we have 3 ohms resistance. So we're going to put a little R here, 3 ohms. And then we have amps of 4. So there we go. And what we're trying to find is we're trying to find the voltage. So this is what that's going to look like. So now I'm going to go over and look at this relationship. I'm looking for E over here, voltage. So I'm going to look, and I've got an I and an R. So I look over here, and I've got a relationship right here that says I and R, where E is equal to I times R. So I end up with an equation that says E is equal to I times R. So I write down what my I is. I already know I labeled it. You don't have to do this. You could just label it off the problem. I write down what my R is, and P, I don't need it. Not going to be used at all. Once you have that information, then you're just going to plug it in. So I'm going to put this over here. I go through and I do 3 times 4. I end up with 12 volts. It's that easy. So really it's about labeling what you know, finding the correct equation based off of what you know. I've got an I and an R. I'm looking for an E. So I start off in the circle. What am I looking for? E. I've got an I and R. Here's the equation. My units are going to be volts because that's what E is written in. That sounds like a lot. Let's look at another problem. Maybe this will help solidify the idea in your head. So find the current in a circuit with a 5 ohm resistor connected to a 12 volt battery. So the first thing I suggest that you do is, after you've written the problem down, is label the pieces that you know. So we've got 5 ohms, that's resistance, and 12 volts. Okay, so 12 volts, and that's the one that I think is going to throw you off a little bit, but remember that volt is electromotive, and that's where the V comes from. So that's our E. And we're trying to find current. So when we're finding current, that's the I. Well, once again, the P does nothing. So we're trying to find the I. So when I look over here, I'm going to start in the middle of the circle for I, the blue stuff. And then I'm going to find the equation that goes with E and R. So I've got an E and an R, so it's right here. It's E over R. So my equation is I equals E over R. So I know what my E is. It's 12 volts. I know what my R is. It's 5 volts. So I can divide them, and I end up with my final answer, which is that I is 2.4 amps. And again, check that you have the right simple, right units. Okay, let's try one last example. Find the power delivered in a circuit with a 3 ohm resistor connected to a 6 volt battery. So we're going to start off the same way with labeling. So we've got a 3 ohm resistor, 6 volts, electromotive V. So there's the E, electromotive. This time we're going to be using the P because we're trying to find power. So we look over towards the P, power in watts. And then we look for what formula that one is. We have an E and an R, so which one has an E and an R? And it's this one right here. It says E squared over R. So my equation is going to be E squared over R. I know that my E is 12 volts, and I know that my R is 5 volts. So I do, sorry, that's the wrong, not 12 volts. I did not change that. That did not get changed. Forget about those. Sorry, my E is 6 and my R was 3. So it's 6 squared, which is 36, and 3. 36 divided by 3 is 12 watts. So that's the power in that circuit. I hope that these 3 examples will help you with solving for an unknown quantity. Again, if you have 2 quantities, using this chart, you can solve for the missing one. Ask me if you have any questions, and good luck.